take a look at our last three parent functions, which are also our parent functions with asymptotes. The first one is the exponential parent function. Our exponential parent function, technically the actual parent function is f of x equals e to the x. Now, e is an actual number. It's an irrational number, meaning it's a decimal. If you were to type in your calculator, that just goes on forever. So e is approximately 2.71, and then it just goes on forever. So because this base e is is a decimal, what we do instead is we use 2, which is pretty close to 2.71 instead. It gives us a similar graph. It gives us the idea of what's going on with the function without having to deal with a whole lot of decimals every time we input anything in. But just wanted to share that information with you. This is one of the parent functions we learn more about towards the end of the school year. But for now, we need to be able to create a table. So we're going to do the same thing. We're going to do some negatives, 0, and some positives. So let's begin inputting value. So let's do f of 0, for example. Hopefully you recall your exponent properties from Algebra 1, and then anything to the 0 power is 1. F of 1 means 2 to the first power, so that's 2. F of 2 is 2 squared, so 4. And f of 3 is 2 to the third power, so 2 times 2 times 2, which is 8. Let's talk about negatives. So f of negative 1 means we have 2 to the negative 1 power. I'm going to go to the side here for just a second to remind you that in Algebra 1, you learned that if you have a negative exponent, you move it to the denominator and becomes a positive exponent. So in other words, 2 to the negative 1, if we transfer that information, is 1 over 2 to the first power. So therefore, 1/2. And then if we do f of negative 2, that's 2 to the negative 2, meaning 1 over 2 to a positive second power. So 1/4, and continue as such with 1/8. Let's graph. So obviously we have some fractions, so it's very important that the ones that are pretty, we are very intentional about. So let's see, 0, 1, 1, 2, 2, 4, and 3, 8. Now, even though those other ones are fractions, we want to include at least 2 of them. So for example, when we go to negative 1, we go to 1/2. When we go to negative 2, we go a little lower, kind of make it look like a 1/4. And then let's think about what is actually happening to our graph. This is going to continue getting smaller and smaller and smaller and smaller. Never actually becoming 0, but getting really close to it. So here's what that means for us. On the left side, we're just getting really, really close to the x-axis, but not actually touching it. And then on the right side, kind of the reason why it's called the exponential function, we are growing at an exponential rate, so very quickly. Here's what this means. The fact that we are getting really, really close to the x-axis and not actually touching it creates an asymptote, which we denote by drawing a dashed line. So it's an imaginary line that is technically part of our graph, and it's something we just approach, get really close to, and never actually touch. So let's see. X-intercept, well, that asymptote blocks us from being able to touch the x-axis, so we actually don't have one here. We do, however, have our y-intercept at 0, 1. Let's talk about our domain. So our domain, if we think about it left to right, we do have all real numbers. However, if we think about our range, bottom to top, we start out at 0. We go to infinity. However, that asymptote, since we never actually touch it, we put a parentheses there. For our asymptote, it's technically a line, so it's a horizontal line, which we will denote as y equals 0. We don't actually have a minimum. We never really get close, or we get close to 0 but never actually touch it. And we also don't have symmetry. So that is our exponential parent function. Our next parent function is our logarithmic. Now, the good news is you don't have to say that word too many times because we usually abbreviate it and just call it a log. Now, in Unit 2, we will learn about inverses, but for now, we will need to briefly understand what inverses are because exponential and logarithmic functions are inverses of each other. And in fact, using that idea is the only way we can actually graph a logarithmic function. So what do I mean by that? First of all, the equation, because we use base 2 for our exponential, we will also use base 2 for our log. So here's what a log looks like. We read it as log base 2 of x. So that 2 is a little subscript. And it's read log base 2 of x. Now, exponential and logarithmic functions are inverses of each other. When two functions are inverses of each other, what that means is that their inputs and outputs are reversed. So the x's become the y's and the y's become the x's. In fact, that is the only way to graph a log, by taking the exponential, for example, taking the x values of the same base and turning it into our y values. So in other words, I will literally copy down every single x value from above, but into my y column. And I will copy every y value into my x column. So again, for inverses, you switch the x and the y values. So this is then our log base 2 of x. Let's go ahead and graph that. Maybe start on the right side. That's where our nice and pretty points are. So we have 1, 0, 2, 1, 4, 2, and 8, 3. So on the right side, it's going to do something like this. And let's see what happens on the left. So on the left, let's do a 1/2. So at an x value of 1/2, I'm at -1. At an x value of 1/4, I'm at -2. And what will happen, similar to our exponential, we will now get really, really close to our y-axis, therefore creating an asymptote there. Again, an asymptote is a line that we approach but never actually touch, and we denote with a dashed line. Okay, in this case we do have an x-intercept. So we have an x-intercept at 1, 0. However, because of our asymptote, we have no y-intercept, so none. Our domain is now 0 to infinity. Our range is all real numbers. And our asymptote has switched to x equals 0. Also no minimum or maximum because of our negative to infinity to positive infinity. And we do not have any symmetry. Okay, moving on to our very last one, which is the rational function. The rational function, first of all, goes by a couple of different names, so you might see these at some point in time. It goes by the inverse function or the reciprocal. So if you hear those words, they all refer to the rational function. And our equation is the following: f of x equals 1 over x. All right, let's do our usual inputs: -3, -2, -1, 0, 1, 2, and 3. All right, let's go ahead and input. So f of 1 is just 1 over 1. F of 2, 1 over 2. F of 3 is 1 over 3. Let's back up. I'm going to come back to 0. F of -1 is 1 over -1, and I think you get the point. But let's do one more. F of -2 is 1 over -2. So -1/2, -1/3, and so on. Let's think about what happens at 0. F of 0 would be 1 over 0. This is usually the part where people want to say either 0 or undefined. In algebra, if we try to divide by 0, our value will always be undefined. So we are not allowed to divide by 0. In other words, 1 over 0 is not possible, so we say undefined. So we will not have a value at an x of 0. The output is undefined. So let's graph and see what this looks like. Let's start with the points. Nothing at 0. So we start with 1, 1. At 2, we're a half. At 3, we're just a little closer. Then go on to the left side. At -1, we're at -1. At -2, we're at -1/2, and at -3, we're at -1/3. Kind of hard to get those on there. Now, at this point, it's kind of hard to see what's happening. So, let me show you this. If you think about what's happening on the right, is that number again will get smaller and smaller and get really close to the x-axis. Similarly here, we get really close to 0, but never touch the x-axis there. However, that graph is incomplete. So here's how I can help you understand the rest of it. What we do is this. So let's pick a number between 0 and 1, and let's go a little crazy. Let's pick 1 over 100, for example. So 1 over 100 is between 0 and 1. So if I take that and say f of 1 over 100, that is 1 over 1 over 100. If you recall, when you divide by a fraction or with a fraction, it's times the reciprocal. That's 100. That is way up there. So what happens here is it gets really, really close to the y-axis. It just keeps growing, but never actually touches it. And similarly here. So this is the complete shape of our rational parent function. We have no x-intercept, no y-intercept because of our asymptotes. I'm going to come back to the domain and range. let's talk about our asymptotes, so the lines that we're approaching. We're approaching the y-axis, and we're approaching the x-axis. So both x equals 0 and y equals 0 are our asymptotes. Let's talk about our domain. So our domain is we're coming from the left. We start at negative infinity. Notice I'm leaving some space. You probably see what's about to happen. Now, this vertical asymptote blocks us from being able to touch zeros in x value. So this is the type of example where we have to take a break at 0, close it with the parentheses since we never touch, and then immediately pick it up again at 0 and take it to infinity. This is our way of excluding 0, taking a break and using parentheses to denote. Very similarly, we deal with our range. We start from negative infinity from the bottom, stop at 0, and then take it 0 to infinity. We do not have our maximum or minimum because of our range being going down all the way to negative infinity, up all the way to positive infinity, even though we take that break. And if we were to fold this, we could say that this is symmetric across the origin. Now, part of your assignment, so those are all our parent functions, part of your assignment, you will be required in part 1 to accurately graph all the parent functions. This is very important. As far as turning in your assignment, you can turn them once per parent function. However, in order to accurately prepare for your quiz or your test for this unit, you need to keep practicing graphing every single parent function until you can do it without looking at your notes. So that means just by knowing or given the rational function, you should know the equation, know how to create a table, therefore create a graph, and then as you see, being able to answer questions come straight from your graph.